When dealing with a 277/480 volts Y service and needing to derive 120/208 volts Y and 600 volts delta, it's important to understand the transformer configurations. Let's address the first transformer, intended to step down 277/480 volts to 120/208 volts. The supply house is correct in suggesting a 277/480 volts delta primary to 120/208 volts Y secondary transformer. The reason for this lies in the phase shift relationship required to establish a proper Y secondary. A delta primary allows for the creation of the necessary phase angles to produce a balanced 120/208 volts Y output. Consider the second transformer meant to convert 277/480 volts to 600 volts delta. In this case, the supply house is incorrect. A 277/480 volts Y primary to 600 volts delta secondary transformer is the appropriate choice. The Y primary helps balance the voltage across the phases of the delta secondary, ensuring stable operation. Now let's delve into the reasons behind these configurations. Firstly, the 120/208 volts Y configuration is selected for the secondary side to provide a neutral conductor. This neutral is essential for accommodating single-phase loads and maintaining voltage balance between phases. Secondly, the 600 volts delta configuration is implemented on the secondary side to achieve a balanced voltage among the phases and minimize harmonics. The primary voltage of a transformer must always be compatible with the incoming power source. Since the incoming power source is a 277/480 volts Y system, the primary windings need to be chosen accordingly. Therefore, to summarize, order a transformer with a 277/480 volts delta primary and a 120/208 volts Y secondary. And also order a transformer with a 277/480 volts Y primary and a 600 volts delta secondary. In electrical power systems, transformers play a crucial role in voltage transformation. They enable the efficient transmission and distribution of electrical energy. Understanding transformer connections such as Y and delta is essential for designing and operating electrical systems safely and effectively. A transformer consists of two or more coils electrically isolated but magnetically linked, allowing energy transfer between circuits at different voltage levels. The primary winding is connected to the input voltage, while the secondary winding provides the output voltage. The ratio of turns between the primary and secondary windings determines the voltage transformation. Y and delta connections are two fundamental ways of connecting three-phase transformer windings. In a Y connection, one end of each winding is connected to a common point, forming a neutral point. The voltage between each line and the neutral point is the phase voltage, while the voltage between any two lines is the line voltage. In a delta connection, the windings are connected in a closed loop, forming a triangle. The line voltage and phase voltage are the same in a delta connection. The choice between Y and delta connections depends on the specific requirements of the electrical system. Y connections are often used when a neutral conductor is required, while delta connections are suitable for applications where a balanced voltage is critical. In the case of stepping down 277/480 volts Y to 120/208 volts Y, a delta Y transformer is used. The delta primary winding provides a phase shift that allows the Y secondary winding to produce a balanced 120/208 volts output. Without the delta primary, the phase angles would not align correctly, resulting in an unbalanced voltage. For stepping down 277/480 volts Y to 600 volts delta, a Y delta transformer is used. The Y primary winding ensures that the voltage across the delta secondary winding is balanced. This configuration helps to minimize harmonics and maintain a stable voltage output. When selecting transformers, it is crucial to consider the voltage ratings, kV amps rating, and impedance. The voltage ratings must match the input and output voltages of the electrical system. The kV amps rating must be sufficient to handle the load requirements. The impedance affects the voltage regulation and fault current levels. Furthermore, it's essential to ensure that the transformers comply with relevant standards and regulations such as those established by the National Electrical Code (NEC). The NEC provides guidelines for the safe installation and operation of electrical equipment, including transformers. Proper grounding is also crucial for transformer installations. Grounding helps to protect against electrical shock and equipment damage. The grounding system must comply with the requirements of the NEC. Regular maintenance is essential for ensuring the reliable operation of transformers. Maintenance tasks include inspecting the windings, checking the oil level, and testing the insulation resistance. Any issues should be addressed promptly to prevent failures. In summary, selecting the correct transformer configurations for a 277/480 volts Y service involves understanding the principles of Y and delta connections. The delta Y transformer is used to step down 277/480 volts Y to 120/208 volts Y, while the Y delta transformer is used to step down 277/480 volts Y to 600 volts delta. Proper transformer selection, installation, and maintenance are essential for ensuring the safe and efficient operation of electrical systems. When installing a new 277/480 volts Y service and wanting to feed both 120/208 volts Y and 600 volts delta, it's vital to get the transformer configurations right. For the 120/208 volt Y output, using a 277/480 volts delta to 120/208 volts Y transformer is crucial. The delta primary helps maintain the phase shift needed for a balanced Y secondary. For the 600 volts delta output, a 277/480 volts Y to 600 volts delta transformer is the correct choice. The Y primary balances the voltage across the phases of the delta secondary, ensuring stability. Now let's dive deeper into the reasons behind these specific configurations. The 120/208 volts Y configuration is chosen to provide a neutral conductor, essential for single-phase loads and to balance voltage between phases. The 600 volts delta configuration is selected to provide a balanced voltage and reduce harmonics. It's important to remember that the primary voltage of any transformer must match the incoming power source, which in this case is 277/480 volts Y. So, to reiterate, order a transformer with a 277/480 volts delta primary and a 120/208 volts Y secondary, and another with a 277/480 volts Y primary and a 600 volts delta secondary. When dealing with three-phase power systems, understanding transformer connections is vital. A transformer is a device that transfers electrical energy from one circuit to another through electromagnetic induction. It consists of two or more windings electrically isolated but magnetically linked. The primary winding is connected to the input voltage, and the secondary winding is connected to the load. The ratio of turns between the primary and secondary windings determines the voltage transformation. Y and delta are two common ways of connecting three-phase transformer windings. In a Y connection, one end of each winding is connected to a common point, forming a neutral. The voltage between each line and the neutral is the phase voltage, and the voltage between any two lines is the line voltage. In a delta connection, the windings are connected in a closed loop, forming a triangle. The line voltage and phase voltage are the same. The choice between Y and delta connections depends on the application. Y connections are often used when a neutral conductor is required, while delta connections are suitable for applications where a balanced voltage is critical. When stepping down 277/480 volts Y to 120/208 volts Y, a delta Y transformer is used. The delta primary provides a phase shift that allows the Y secondary to produce a balanced 120/208 volts output. When stepping down 277/480 volts Y to 600 volts delta, a wide delta transformer is used. The Y primary ensures that the voltage across the delta secondary is balanced. When selecting transformers, consider the voltage ratings, kVA amps rating, and impedance. The voltage ratings must match the input and output voltages. The kVA amps rating must be sufficient to handle the load. The impedance affects the voltage regulation and fault current levels. Always comply with relevant standards and regulations such as the NEC. The NEC provides guidelines for safe installation and operation. Grounding is crucial for protection. The grounding system must meet NEC requirements. Regular maintenance is essential for reliability. Inspect the windings, check the oil level, and test insulation resistance. To sum up, correct transformer configurations for 277/480 volts Y service require a solid grasp of Y and delta connections. Use a delta Y transformer for stepping down 277/480 volts Y to 120/208 volts Y, and a Y delta transformer for stepping down 277/480 volts Y to 600 volts delta. Proper selection, installation, and maintenance are critical for safety and efficiency. Now let's talk about power quality issues. Transformers, while essential, can also be sources of harmonics. Harmonics are voltage and current distortions that can cause problems for sensitive electronic equipment. Delta connections can help mitigate harmonics by providing a path for harmonic currents to circulate within the transformer windings, preventing them from propagating into the power system. However, it's important to note that delta connections can also amplify certain harmonics under certain conditions. Proper transformer sizing is crucial to prevent overheating and premature failure. The transformer should be sized to handle the expected load, with some margin for future growth. Overloading a transformer can lead to insulation breakdown and reduced lifespan. Transformer efficiency is another important consideration. Energy-efficient transformers can save money on electricity bills and reduce greenhouse gas emissions. Look for transformers that meet or exceed industry efficiency standards. In addition to the NEC, other relevant standards and guidelines apply to transformer installations. These include standards from the Institute of Electrical and Electronics Engineers, IEE, and the National Electrical Manufacturers Association, NEMA. These standards cover topics such as transformer testing, performance, and safety. When installing transformers, it's important to follow the manufacturer's instructions carefully. Proper installation is essential to ensure safe and reliable operation. This includes things like providing adequate ventilation, using the correct wiring methods, and properly torquing connections. Regular inspections are crucial for identifying potential problems before they lead to failures. Inspections should include checking for signs of overheating, leaks, and corrosion. Any problems should be addressed promptly. Transformer oil is used to insulate and cool the transformer windings. The oil should be tested regularly to ensure that it is free of contaminants. Contaminated oil can reduce the transformer's insulation strength and cooling capacity. Proper disposal of all transformer oil is essential to protect the environment. Transformer oil can contain polychlorinated biphenyls, PCBs, which are harmful pollutants. Always follow local regulations for the disposal of transformer oil. In summary, transformers are essential components of electrical power systems, but they require careful selection, installation, and maintenance. Understanding the principles of Y and delta connections is crucial for selecting the correct transformer configurations. Proper sizing, efficiency, and maintenance are essential for ensuring safe and reliable operation. Following relevant standards and guidelines is crucial for compliance and safety. When installing a new 277/480 volts Y service and needing to derive both 120/208 volts Y and 600 volts delta, it's vital to get the transformer configurations right. For the 120/208 volts Y output, using a 277/480 volts delta to 120/208 volts Y transformer is crucial. The delta primary helps maintain the phase shift needed for a balanced Y secondary. For the 600 volts delta output, a 277/480 volts Y to 600 volts delta transformer is the correct choice. The Y primary balances the voltage across the phases of the delta secondary, ensuring stability. Now let's consider the scenario where you want to add a 480 volts delta system. In that case, you could use a delta-delta transformer connected to your 480 volts Y system, but it's generally not recommended. Instead, you would need an isolation transformer that converts your 277/480 volt Y into 480 volts delta system for specific equipment needs, because safety is paramount. The 277/480 volts Y primary to 480 volts delta secondary allows for equipment that absolutely requires delta power, but it's very rare. Let's dive deeper into why these configurations are so important. First, the 120/208 volts Y is standard for single-phase loads and balancing phases. Then the 600 volts delta delivers the balance voltage and minimizes harmonics. Remember, the transformer's primary voltage must match your source, which is 277/480 volts Y. Order your first transformer with 277/480 volts delta on the primary and 120/208 volts Y on the secondary. Then, order your second transformer with 277/480 volts Y on the primary and 600 volts delta on the secondary. Let's discuss NEC requirements too. Section 450.321 states the overcurrent protection requirements for transformers over 600 volts. The NEC requires that transformers be protected against overcurrents. This protection is typically provided by fuses or circuit breakers. The size of the overcurrent protection device must be coordinated with the transformer's kV amps rating and impedance. The NEC also specifies requirements for transformer grounding. Transformers must be grounded in accordance with Article 250. The grounding system must be designed to provide a low impedance path for fault currents. The NEC also includes requirements for transformer clearances. Transformers must be installed with adequate clearances to prevent overheating and to allow for maintenance. The NEC also addresses the issue of transformer oil. Transformers containing oil must be installed in accordance with Section 450.27. The oil must be contained in a suitable enclosure to prevent spills. Let's talk more about harmonics and how to mitigate them. Harmonics are caused by nonlinear loads, such as electronic devices and variable frequency drives. Harmonics can cause a variety of problems, including overheating of equipment, voltage distortion, and interference with communication systems. There are several ways to mitigate harmonics. One approach is to use harmonic filters. Harmonic filters are designed to block harmonic currents from propagating into the power system. Another approach is to use harmonic-reducing transformers. Harmonic-reducing transformers are designed to minimize the generation of harmonics. In summary, when working with electrical systems, it is essential to understand transformer connections and NEC requirements. Following these guidelines will help ensure safe and reliable operation. So, getting back to the subject matter, be sure to consult with a qualified electrical engineer to ensure that your transformer installations comply with all applicable codes and standards.